All right, let's talk about what's going on with air, or maybe no air, on Mercury. Mercury, closest planet to the sun, and check this out, it doesn't really have air. Part of the reason for that is it doesn't have much gravity to kind of hold that air in place. Part of the reason the Earth has air is gravity is helping to keep the air here. That's one component. The other component that's kind of hurting Mercury is it's so close to the sun. The sun's actually constantly sending out charged energy. It's called solar wind. This charged energy, you know what it's good at? Taking air away from planets. Mars doesn't have any air on it because it doesn't have a magnetic field to play defense to that charged energy. Earth has a magnetic field to kind of keep out that charged energy from the sun. Well, this one does not have defense so much. It doesn't really have much of a magnetic field. So the sun, any little air that is there, is able to strip it away. It doesn't really have gravity to hold the air. So needless to say, we're not breathing on Mercury anytime soon. Get this one, 800 degrees. Look at that. Mercury's around 800 degrees during the day just because it's so close to the sun. At night, so when it's not getting sunlight, negative 330. Doesn't sound like a place that I want to be living on. It's also one of those planets where it's kind of like a desert, even though it gets really hot in the day, it's cold at night because the ground doesn't really hold on to heat. Same sort of deal there. All right, let's go to Venus. So we're getting a little farther from the sun. We're getting closer to the Earth. Venus has way more air than Earth. It's got about 90 times more air than our air. What's interesting is its air is mainly a greenhouse gas, carbon dioxide. And the more greenhouse gases you have, the warmer your planet's going to get. So on average, the temperature is around 800 on Venus just because of all those greenhouse gases. They're really good at, what they do best is they get the heat that is at the ground and they send it right back down to the ground. Our Earth, for scale, only has about less than 1% greenhouse gases. If we had way more greenhouse gases, our average temperature would be way, way warmer, kind of closer to that negative 800, depending upon how many we have. So here's what's interesting. Little sunlight actually reaches Venus's surface, but those greenhouse gases, they capture some of that sunlight, and they're good at just giving that sunlight off, sending kind of back down. So clouds cover the planet, and they're reflecting actually a good portion of the light that actually comes into the planet. Only about 25% is coming in, but of that 25% of that sunlight, those greenhouse gases do a really good job of locking in that heat. Kind of interesting. Our Earth, we're in good shape. What's interesting is most of our air, not oxygen. Most of the air, what you just breathe in right now, 80% nitrogen gas, not oxygen. Only about 20% of what you just breathe in right now, oxygen gas. How interesting is that? Our magnetic field, we love it, playing defense, keeping out that charged energy from the sun that basically strips away the air on Mars. There's virtually no air on Mars just because it doesn't have a magnetic field. It doesn't really have a magnetic field because you need some, essentially magma churning around as the planet spins, and that leads to magnetic field building up. This one, not so much. There's some kind of more interesting research that's still coming out. We're still trying to understand kind of what's on the insides of Mars. So let me kind of break this down, first of all, a little bit more about Mars itself. What little air it does have, and it virtually has no air, is mainly carbon dioxide, so it's kind of like similar to Venus in that respect. Air leads to our sky being blue, and as a result, since there's virtually no air on Mars, the sky in Mars is not going to look blue. It's going to have a brownish gray look to it. Kind of cool. That's what happens when you don't have air. You need air, or at least our type of air, to get that blue sky. Depends what kind of air you would have to what color sky you have. If you don't have air, then we saw it's kind of like a brownish gray for the sky. How cool is that? So Mars itself, it's got clouds made of some humidity, we'll call it, water vapor. That's the moisture in the air. Dust, that's what you need for a cloud. Farther from the sun, so it's getting less sunlight. They get like 40% the amount of sunlight that we get. And, it's not going to be a place you're going to be breathing on. Since there's no air, you're not going to be growing plants outside. Mars also, another problem, besides lack of air for growing plants. Look at this. 0 to 60 during the day, but negative 160 to 250 at night. The ground, very rocky, kind of desert-like, doesn't retain heat. And what's cool is you can check out some of the weather on Mars. Here's a snapshot from 2020. The high was 24 degrees, the low negative 140. Think of the ground there. I don't want to call it soil because when I say soil, I think of like planting soil, like it's kind of dark. It's got a lot of organic material like nutrients, aka broken down pieces of plants or food in it. The ground on Mars is basically just crushed rock. It's pretty much all it is. Not the best for plants to grow in. You'd actually need to add some fertilizer to the crushed rock to make plants grow. What's cool is you can get simulated Mars soil from online. Essentially, it's just crushed rock. And it's coming from the Sonora Desert out in California. It looks like this right there because scientists have found out that's what's very similar to the ground on Mars. And if you want to mimic what it would be like to grow something on Mars, here's what you do. You get that, you mix it with basically some worm poop or fertilizer, and you can grow stuff. And Villanova University did that. And they found what grows the best are actually leafy greens. In particular, dandelions, like dandelion flowers, do really well. So the movie The Martian, they had the right picture by you got to grow things in a greenhouse. One, you can't grow it outside. It's too cold, not enough air. So those are some issues right there. But the kind of the science of Matt Damon right there, adding his fertilizer, his own fertilizer, to the rocky soil and plants grow, yeah, that would happen. That was good science right there. Bad science in the movie is he would not walk normally because there's actually less gravity since Mars doesn't quite have the width and the weight that Earth does. So there's not as much gravity anchoring you down. On Mars, it's going to be more like on the moon how you move. You're going to have big bounces. You're not going to walk normally. So that was one bad little thing there. Jupiter and kind of the rest of the planets we talk about, they're all kind of similar here from here on out. So Jupiter, it's got air because, for one, it's got a magnetic field to play defense to block out some of that solar wind. And the air that's there, it's mainly hydrogen, which is one of the building blocks of water. The gas form of water, that moisture in the air, water vapor, it's H2O, so hydrogen. So that's interesting there. It's got clouds that swirl around. It's got jet streams. Jet streams are just like moving air, or big kind of like paths and tracks of moving air. And it keeps swirling because there's not really a ground. There's not friction to slow it down. When we have wind, part of the reason it's not windy here every day is the ground and the buildings, the trees slow down that wind. They act like friction and they erode it and the wind stops. Out on the plains where they really don't have trees really because it's too dry and it's just flat fields, it's usually windy every day because there's less things to stop the wind. This doesn't have really ground friction to stop the wind, so it's always windy, so stuff just keeps moving around. Kind of higher up, the clouds, negative 300 degrees because it's farther from the sun. We're pretty far out now. And yeah, you're not going to be standing on there. It's just a big ball of gas. That magnetic field's kind of, and not only magnetic fields is helping to kind of keep that ball of gas together, it's got gravity to it, so that's also keeping it together. But what's interesting is the warmer inside, the more inside the planet you go, the warmer it gets. And what creates wind, one of the ways you create it is temperature differences. So hot and cold is going to make wind when you put those two next to each other. So it makes sense there's moving air. There's wind on this planet because as you go closer into the center, it gets warmer. While there's not like really any ground to stand on, it kind of at the very center, it does have a rocky core. Planet super hot. Look at that in the center, 36,000 degrees, super hot. The reason it's so warm is all the weight of the air on the planet, it gets so intense at the center, it makes things crazy hot. For example, part of the reason we actually have magma way below our feet, so magma is just lava that comes out of volcanoes, except when it's below ground, you call it magma. Part of the reason we have a liquid inner core to our Earth is the weight of the Earth, literally, all around it is so intense, that pressure, the force squeezes it so much, and with so much intensity, it essentially makes a solid liquid. Like it makes it so hot, it just melts everything just because of the pressure. And that's what's going on here. All the pressure of all that air leads to a really hot center. So I think that's kind of neat. So Saturn, it's pretty much the same story as we just talked about. It's not like Jupiter. It's windy. It's kind of cold at the outer surface. So it's talking about cold clouds here at negative 400 degrees at the upper levels of Jupiter. But when you get in the inside from all that intense pressure, it's 20,000 degrees. And we're talking plus there. And that's going to lead to wind and things like that. It's It's got a magnetic field to block out the solar wind, so he helps keep the air in place. And its air also mostly hydrogen. In the other planets that we're going to talk about, Uranus, Neptune, kind of similar stories. Their air is going to be a little different, and that leads to the color. We talked about what air is made of. Sunlight moving through it leads kind of to what the sky looks like, so that leads to why some of these are blue. So both of these planets, mainly hydrogen air, they're solid in the very center, mainly from the pressure. It's really warm in the very center, cold on the very outside. Why are you cold? You're far away from the sun. Super windy because of that temperature difference. Got the magnetic field to play defense so they can retain their air, playing defense from that charged energy from the sun that would strip away the air. Neptune is blue, Uranus blue-green because of the air. One of the colors coming from methane. So that's about 1% of Neptune's air, 2% of Uranus's. And that gas, it does a really good job at absorbing the warm colors in sunlight. Sunlight is made up of all different colors of the rainbow. So that gas does a good job of taking in the reds and colors like that, but it doesn't do a good job of taking in absorbing the colder colors, the blues, the greens. Instead, those colors just kind of get more reflected all around, and that's what leads to that color itself. That's actually how we have our blue skies. The blue in sunlight, as it moves through air, our air does a really good job of reflecting that blue all around, and so our sky is blue. And there, some of those gases, the methane, and then the methane itself on those two planets, Neptune and of course Uranus, it just helps to aid to that color. I think it's kind of neat. So those are the planets. And what's neat is NASA eventually taking us to Mars, getting some human bodies on it, even though we got the robots on it now. But NASA's also constantly sending up rockets. Not only rockets that would take astronauts to these planets, but also rockets that are taking up satellites and all sorts of different things, or like that Webb telescope. And so these slides right here talk about what it's like to launch something into space. I got to go to a rocket launch. I got to see Mission Control right there. And what's interesting is a rocket is taking off as long as the scientists don't hit the stop button. There's no button to launch it. The computer's taking it up. There's only a button to stop it. Why? Computers are smarter than us, so even up to the millisecond before something launches, the computer's checking to make sure everything's okay. That's where NASA used to launch some of the giant space shuttles into space back in the day. I got to check that out in Florida. Kind of cool. That's the building where they put these space shuttles and rockets together. It's 17 stories, but it's only one large room. That right there is 17 stories, and that right there in the center is going to be what they're going to send astronauts to Mars on. So cool. This thing's called a crawler, and what it does is it literally takes that from the building where it got assembled to the launch pad where it's heading, and it moves very slowly. That's essentially the train tracks for the crawler. There's the launch pad where you send some of these rockets or space shuttles into space. This right here, they're getting it ready for the space shuttle that's going to space. I got to stand where the space shuttle that's going to take astronauts to Mars lifts from right there. And in that, if you see there in the center, this blast wall right there is to focus the fire from the rocket engines to go a certain way. To go that way, head toward the water. I think it's so cool. By the way, most of the shape of a rocket itself is actually fuel. So if we step back for a second here, most of this right here is fuel, and at the very top is where the astronauts would be. Because you need a lot of fuel to get this sucker in space. I think that's also interesting of how that all works. So I got to see this rocket launch, and you can see what it was like to go check out a rocket launch online. And this talks about once you get a satellite into space, you want it to move with the Earth. It kind of hovers right where the equator is, but farther away. And as the Earth moves, it moves with it at the equator line, but way out in space. That's a geosynchronous satellite. Geo meaning Earth, sync means it moves with the Earth.